In 1952, a scientist named Rosalind Franklin worked alone in a basement laboratory at King's College in London. The room was cool and quiet. The only sounds were the soft hum of equipment and the careful movement of her hands. She prepared a thin sample of DNA with great patience. She stretched the fibers until they were perfectly aligned. She adjusted the humidity in the room so that the moisture level was exactly right. Then she placed the sample in an X-ray machine and waited. When the photograph finally appeared, it showed a clear X-shaped pattern of dark spots against a light background. That single image would later help the world understand the true shape of DNA, the molecule that carries the instructions for every living plant, animal, and human being. Yet for many years, the woman who created the photograph received little public recognition for her part in one of the greatest scientific discoveries of the 20th century. Rosalind Elsie Franklin was born on the 25th of July, 1920 in Notting Hill, a residential area of London. Her family was Jewish and placed a high value on education and hard work. Her father, Ellis Franklin, worked as a banker during the day and taught evening classes for working people in his free time. Her mother, Muriel, spent many hours helping charitable organizations. The Franklin home was filled with books, newspapers, and serious discussions about the events of the day. From early childhood, Rosalind showed a strong desire to understand how things worked. While other children played games in the streets or parks, she preferred to ask questions. She wanted clear answers based on evidence rather than simple stories or guesses. Family members later remembered that even as a small girl she would argue her points carefully and refused to accept explanations that seemed incomplete. Her teachers at school quickly noticed her unusual focus and care. She performed especially well in mathematics and science. She kept neat notebooks and checked her work more than once. At the age of 15, she told her family that she wanted to become a scientist. The decision surprised her father. In the 1930s, most people believed that advanced science was a field best suited for men. He hoped his daughter would choose a more traditional path such as teaching or social work. Rosalind listened to his concerns with respect, but she did not change her mind. She was determined to follow the path that interested her most. In 1938, she entered Cambridge University to study chemistry. Cambridge was one of the oldest and most respected universities in the world. Yet it was still a difficult environment for women. Female students were not always treated as full equals. Some facilities and discussions were reserved for men. Rosalind paid little attention to these barriers and concentrated on her studies. She worked with great precision in the laboratory. Her notes were detailed and organized. She planned each experiment carefully and repeated measurements until she felt certain of the results. Her professors observed that she had a special talent for careful observation and for noticing small details that others might miss. When the Second World War began, many young scientists were asked to contribute to the national effort. Rosalind joined a research project that examined the structure of coal and carbon materials. Coal was essential for industry and for the production of protective equipment such as gas masks. Using X-ray techniques, she studied the tiny internal arrangement of atoms inside different types of coal. Her findings helped scientists classify coals more accurately and improve the quality of materials used by soldiers and workers. The research was practical and useful. It also earned her a doctoral degree when she was only 26 years old. By that time, she had become highly skilled in X-ray crystallography. This method uses beams of X-rays to create patterns that reveal the arrangement of atoms inside crystals and complex molecules. Reading those patterns required patience, experience, and a sharp eye for detail. After the war, Rosalind moved to Paris to work in a research laboratory. The years she spent in France were among the happiest of her life. The laboratory atmosphere was open and cooperative. She made friends among her colleagues and enjoyed the daily life of the city. She liked the food, the culture, and the sense of personal freedom. People who worked with her during that period later described her as lively, warm, and ready for interesting conversation. She continued to improve her technical skills and published several important scientific papers. The experience in Paris gave her confidence and a broader view of how scientific research could be conducted in a friendly environment. In 1951, she received an offer to return to England and join the staff at King's College London. The new position involved research on the structure of DNA. At that time, scientists already knew that DNA was the substance that carried genetic information from one generation to the next. What no one yet understood was the exact shape of the molecule. Without knowing the shape, It was difficult to explain how DNA could copy itself and pass instructions to living cells. Research groups in several countries were competing to solve the problem. The first team to discover the correct structure would make a major contribution to biology. Rosalind accepted the position and prepared to begin her work. From the early weeks at King's College, the situation proved uncomfortable. Maurice Wilkins, a scientist who was already studying DNA, believed that Rosalind had been hired to work as his assistant. Rosalind had been informed that she would lead her own independent research on the problem. The difference in expectations created tension between them. Their personalities also differed. Wilkins tended to be quiet and preferred indirect ways of speaking. Rosalind preferred direct and clear discussion. The college itself still followed older traditions. Women were not permitted to enter the main common room where male staff members met for lunch and conversation. As a result, Rosalind often ate her meals alone. She chose not to make a public protest. Instead, she directed all her energy toward the laboratory. The scientific task she faced was demanding. Samples of DNA had to be prepared with extreme care. Thin fibers of the molecule needed to be stretched and aligned so that the X-ray beam would strike them at the best angle. The amount of moisture in the air had to be controlled precisely because water content affected the structure of DNA. The X-ray equipment required constant checking and small adjustments. Rosalind spent many months improving every part of the process. She was patient and thorough. She believed that rushed experiments often produced unclear or misleading results, while careful work produced reliable information. Other research groups were moving more quickly and building models based on incomplete data. Rosalind preferred to wait until her photographs were clear enough to give solid evidence. In May 1952, she obtained the image that later became known as Photo 51. The photograph showed a sharp X-shaped pattern of dark spots. To a trained scientist, the pattern strongly indicated that DNA had a helical shape, similar to a twisted ladder or spiral staircase. The quality of the image was higher than most previous photographs of DNA. Not long after the photograph was taken, Maurice Wilkins showed it to James Watson during a visit. Watson was working with Francis Crick at Cambridge University on the same scientific problem. They had not yet produced an image of equal clarity. The information contained in Photo 51, together with other measurements and data, helped them construct a three-dimensional model of the DNA molecule. The model showed two long strands twisted around each other. Specific pairs of chemical bases held the strands together like the steps of a ladder. In 1953, Watson and Crick published a short paper describing the double helix structure. The discovery was immediately recognized as one of the most important advances in modern biology. It explained how genetic information could be copied accurately and passed from parent to child. Rosalind's contribution was not fully acknowledged in the early public accounts of the discovery. She continued her own careful analysis of the data, and later published papers that supported the helical structure. However, the main public credit went to Watson and Crick. The working atmosphere at King's College remained difficult, so she decided to leave. She moved to Birkbeck College, another institution in London where the environment was more open and welcoming. At Birkbeck, she turned her attention to the structure of viruses. Once again, she applied her skill in X-ray methods and produced valuable results that improved scientific understanding of how virus particles are organized. Throughout these years, she maintained high standards in every part of her research. Colleagues who worked with her at Birkbeck respected her thoroughness, her honesty, and her willingness to share technical knowledge with younger scientists. She continued to publish papers and to train students. Yet the earlier work on DNA remained a sensitive subject that was rarely discussed openly in her presence. In 1956, Rosalind began to feel unwell. Medical examinations showed that she had developed ovarian cancer. The illness progressed rapidly. She continued to work in the laboratory whenever her strength allowed, but the disease could not be stopped by the treatments available at the time. On the 16th of April 1958, Rosalind Franklin died in London. She was only 37 years old. 4 years later, in 1962, the Nobel Prize in Physiology or Medicine was awarded to James Watson, Francis Crick, and Maurice Wilkins for their contributions to the discovery of the structure of DNA. The rules of the Nobel Committee did not permit awards to be given to people who had already died, so Rosalind could not be included. For a long time, many textbooks and popular stories mentioned only the 3 men who received the prize. Gradually, the full historical record began to receive more attention. Scientists who examined the original laboratory notebooks and photographs recognized the importance of Photo 51 and of the precise measurements Rosalind had made. Historians wrote detailed books that described her role in the research. Lectures, articles, and later documentaries brought her name to wider audiences. Over the following decades, her contribution became a standard part of the story of the double helix. Today, most accurate accounts of the discovery include her work and acknowledge the difficulties she faced as a woman scientist in that period. Rosalind Franklin's life offers several clear lessons. Careful and patient laboratory work can produce results that change an entire field of science. Public recognition does not always arrive at the same moment as the discovery itself. Barriers of gender and institutional custom can slow the progress of talented people. At the same time, the quality of the scientific evidence eventually becomes visible when later researchers examine the records with care and fairness. Her photograph of DNA remains one of the most important images in the history of biology. Every time a student learns about the double helix in a classroom, every time a doctor orders a genetic test, every time researchers study the molecule that carries the instructions for life, the work done in that basement laboratory continues to matter. Rosalind Franklin did not live long enough to see the full impact of her contribution, but the scientific community has slowly and steadily corrected the historical record. The story of DNA is often told as a race between brilliant minds, racing toward a great prize. It is also the quieter story of a scientist who prepared her samples with extreme care, controlled every condition in her laboratory, and produced a clear image that made the final model possible. That image came from the skilled hands and patient mind of Rosalind Franklin. What do you think about the way history has remembered her? Do you believe she has now received the recognition she earned through her careful work? Or do you feel that more still needs to be said? Please, share your thoughts in the comments.